Hey, ladies and gentlemen, welcome. We are talking about intro to functions. So, there are three different types. The first one that we're going to talk about is going to be a table, and I'm just going to kind of list them up here as well. We have a table, we have a graph, and we have a diagram. And I'm probably not going to go in that order, and I apologize, but I just want you to know them. So, let's look at a table of functions, and I am so sorry. Trouble drawing a straight line right now. So we have our input and our output. So if we put one in and we get 2 out, then we put 2 in, we get 4 out. We put 3 in, we get 6 out. We put 4 in and we get 8 out. Okay, so these all have these wonderful little rules. This happens to be a function table because each input has one output. So if I put 1, I get 2. If I put in 2, I get 4. Put in 3, you get 6. Put in 4, you get 8. Okay, so if we were to write this, because one of the things we're looking at is how can we write this algebraically? So think back, what variable, what unknown value could we use to represent an input function, to represent our input, what we're trying to find? Good, we can use x. Now, the rule here says I put in 1 and I get out 2. How do you get that? Good, you multiply it by 2. So I can do 2x or x2, and then if x is the input, x is that value that I'm putting into it, what do you think is the value that I'm getting out? Remember, think of the alphabet. What comes after x? Y, I don't know. Good. So I'm just going to rewrite this in a nicer way, and it's really y equals 2 times x. And that's exactly how we do this. Now, I'm going to do the same thing, but I'm going to do this with a diagram. And I apologize right now for my drawing for the diagram. These are kind of hard for me to draw. You would think that these little egg shapes would be easy. 1, 2, 3, 1, you get 1, 3, put in 2, you get 3, put in 3, you get 5. This is a diagram. And what I'm going to try and do is very similar to what I just did. It just, instead of being in this nice boxy shape, I have 2 little loopy things and they connect. That's our diagram. So then the question becomes, what's our rule? How? Well, let's just go over the fact that this is our input, this is our output. How can we do this? How do you get from 1 to 1? Good. You could multiply by 1. However, the same rule has to follow for all of our inputs. So if we multiplied 1 by 1, we get 1. So that gives us that first initial output. But what happens when we multiply 2 by 1? You don't quite get 3, you get 2. So let's start with y equals, because that is our output. So in this case, especially if you watch the Cyber Chase video, they told us we multiplied it, we doubled it, and then you take away 1. So 1 times 2 is 2, minus 1 gives us 1. 2 times 2 is 4, minus 1 gives us 3. So whatever our algebraic rule is for these, it has to follow along with all of this stuff. Okay? Now let's look more so at situations where we have to graph. These are kind of fun. I do enjoy these. I'm starting to anyways. So with our graphs, whenever we have a graph, remember your time goes on the horizontal axis. My vertical, I'm going to call this distance. Okay, so if this is what my graph looks like, what are some situations that we could give this? What are some situations that you could think of that would go along with graph A? Good. So this could be where you are traveling on the highway and you're traveling at a speed that is constant. For example, if you're using cruise control and you're going 60 miles an hour and you don't change, it's a very steady pace. Okay, so one of the other ones though, let's do time. And I'm just going to put D for distance right now. Okay. So this is graph B. What are some possible situations that we could use to represent graph B, or graph B could represent? Good. So if you think about it, it's always possible that we could go, well, let's make kind of like an assumption and say this is home. Well, and then this would be home as well. So this part right here, I'm thinking maybe I went to school. So you're home, then you go to school, you haven't gone anywhere. But this part right here, time goes on. So you're sitting in school maybe 7:40 until 2:40, or you're sitting in school from 8 a.m. until 4 p.m., whatever it is. And afterwards, you get to go home. And that's where we go back home. So that's one. Let me show you another one that I kind of like. And again, I apologize, a little bit of trouble drawing straight lines. Now this one may take some thinking. Okay, so our graph C, and I'm going to erase part of, oh, I guess I'm erasing all of it. Yikes, that was not meant to happen. Sorry about that. Let's try that again. So, distance and time, what are the possibilities? Good, okay. So right here, remember we're stopping. So this could either be a bus or a carpool. We could even be going from school and then we drop someone off. Then you drive some more, drop someone off, drive some more, drop someone off. These are just different possibilities that we can use for our graphs. And what we're going to be looking at is, I'm going to give you a graph, you come up with your own situation. Some of you are very creative. I had one where, unfortunately, I had a flat tire, then my car caught on fire, and this is all what happened. So I'm trying to get home right here, and then I had to stop because I got a flat tire. So I got the spare out and I was able to keep going, and then my car caught on fire. And then I was told that I could keep going, and then my muffler fell off, and then I could keep going. The students keep telling me different things. So these are all wonderful scenarios that you get to decide on. Come back. Right now, this is the intro to functions. This is kind of be part one. Part two, I'm going to look at what is a function. Okay, and I'll talk to you guys later.